A multi-carrier DAS. We'll start with the radios, their dependencies on frequencies, and then we'll define the multi-carrier DAS. I'm sure all of you have seen radios. Most of you have also tuned them to go to your favorite station. If you are tuning into your favorite channel on the radio, you are essentially turning the knob to go to a certain frequency. FM radio channels in the US operates in a frequency band extending from 87.8 MHz to 108 MHz for a total of 20.2 MHz, which is the bandwidth of US radios. We mentioned before that radios are at the core of signal sources. Three things to remember here. Radios used for wireless signal sources are similar, except radios for signal sources can both receive and transmit signals, but radios in our cars can only receive signals. Another big difference is that radios we use in the wireless industry comes pre-tuned, which means they are pre-tuned to only work for, let's say, 700 band or 1900 band. We just have to make sure that we are getting the right radios with the right band. So what are the right bands for signal sources? Let's reframe that question by asking what are the common RF signal source frequency bands in the US. The big operators like Sprint, AT&T, T-Mobile, Verizon, they use 700, 800, 850, 1900, 2100, 2500 megahertz. Here is a table that shows the major wireless service providers of US and the frequencies and technology they use. You don't need to memorize any of this, but it will be good to keep this as a reference. One clarification here, as you can see in the table, more than one carrier can use same band. So for example, 1900 band is shared by all four carriers. This does not mean that all the carriers are using the same channels or frequencies within 1900 band. They all have distinct channels or frequencies within the 1900 band. If they are not distinct and separate from each other, we are going to have a lot of interference problems, which is a bad thing. As far as the technologies, LTE, UMTS, CDMA are all acronyms for wireless technologies used by the carriers. These technologies tell the engineers basically how the signals will be processed. LTE is common among all carriers, although most of the carriers are using LTE to transmit and receive data. In very near future, all carriers will move to voice over LTE or VoLTE and use LTE for carrying voice. Now, let's talk about multi-carrier DAS. A multi-carrier DAS can process signals from multiple radios with multiple frequencies. For example, let's look at a block diagram of a DAS that you have seen before. In a multi-carrier environment, we can share this DAS with AT&T, Sprint, T-Mobile, Verizon. That means they can share the coaxial cable, the fiber, couplers, antennas, etc. Basically the whole DAS infrastructure. It's common in the industry to call a multi-carrier DAS a neutral host DAS. That's really a misnomer. The reason because neutral host means the DAS is neutral to any signal. However, that's not the case in majority of carrier-grade DAS. So I like to call these multi-carrier DAS. Some multi-carrier DAS can also carry public safety signals. Solid DAS platform, for example, will have a separate section dedicated to public safety DAS, but just know that public safety is also often part of the multi-carrier DAS.